Alright everyone, so let's get into the third IB question. This one's labeled number 8, and it says, the normal to the curve x times e to the minus y plus e to the y is equal to 1 plus x at the point P, c comma ln c, and has a y-intercept of c squared plus 1. Find the value of c. So unfortunately for us, it's going to get a little messy because we have two things. We have implicit differentiation because I'm differentiating with respect to x, but my equation involves y. And we also have product rule, right? Because we have two multiplications, or a multiplication over here. So first, let's differentiate implicitly. So I get 1 times e to the minus y. I have here minus x times e to the minus y, and then dy dx for my first implicit differentiation, plus e to the y dy dx is equal to 1. Okay? And now at this point, I'm going to start replacing my values, right? This is going to be my x value. This is going to be my y value, wherever I see it. So, plugging those two values in, I get, what do I have here? 1 times e to the minus ln of c minus c e to the minus ln of c times dy dx. Then, what else do I have? Plus e ln of c dy dx is equal to 1. So not super pretty, but we can deal with it. But all I want to do is isolate, right? I want to isolate dy dx. So these are the two terms that have dy dx in them. This is the term that I want to move over to the other side. And also I want to simplify this as much as I can. So let's start doing that first. Remembering that because this is a natural logarithm, this is a coefficient of -1, I can bring it up here. So what this really is like this exponent, negative ln of c can be written as ln of c to the power of -1, and then this e and this ln can be simplified. That's the reason I'm doing this. So here, just as a little side note, I'm not going to rewrite the whole step, but negative ln of c can be rewritten as ln of c to the -1, right? Turning that into my exponent, so that here, when I get to my next step, I get 1 times 1 over c, right? Because all I'm going to be left with when the e and the ln simplify is c to the -1, and c to the -1 can just be written as 1 over c, minus, and I'm going to perform the exact same type of manipulation up here, but I'm not going to explain it again because we've already explained it once. So I have the minus c multiplied by 1 over c, and then we still have dy dx. I know these two can be simplified, but for the time being, we're just going to take it one step at a time. Plus, again, e and ln simplify, so I'm just left with c dy dx is equal to 1. Now, like I said, let's simplify as much as we can before we move stuff over. So, this stays as 1 over c. This stays as what? C and c cancel, so it's just minus dy dx. Plus, nothing to simplify here, c dy dx is equal to 1. Now I give myself a little bit more room. So, what I'm going to do now is move all of my terms that don't have dy dx over to one side. So I end up with minus dy dx plus c dy dx is equal to 1 minus 1 over c. Okay, and now what am I going to do? I'm going to factor out the dy dx. So moving over here to my next step, dy dx multiplied by, it would be -1 plus c, but I'm just going to rewrite this as c minus 1 to make my life a tiny bit easier, is equal to, and now I'm going to bring this over to a common denominator, so this I'm going to rewrite as c minus 1 all over c. And now I'm just going to divide both sides by this. So I end up with dy dx is equal to c minus 1 over c all over c minus 1. And c minus 1 I can just rewrite as over 1. And it's pretty late, so I am no longer at the point where I can do this smoothly in my head, and I don't want to risk making a mistake. So c minus 1, this is like a little side calculation, I'll put it in a bubble. C minus 1 over c divided by c minus 1 over 1 is going to be equal to c minus 1 over c times 1 over c minus 1. So this and this cancel, and I'm just left with 1 over c. So after this little side calculation, I'm left with dy over dx is just equal to 1 over c. And I can't really simplify my slope any more than that. But now, remember, this is the slope of my tangent. But that's not what I'm looking for. It says it says the normal to the curve at the point c ln c has a y-intercept of c squared plus 1. So that means the slope of my normal is the negative reciprocal of this. So it's minus c. Right? No more fraction, but we do have a negative. And now I take that and plug it into our point slope form, right? I'm given an x-coordinate, I'm given a y-coordinate, and now I have the slope. So the equation of my normal is y minus the y-coordinate we were given all the way up here, ln of c, and that's equal to negative c, which is the slope that we just found, times x minus c. So this is the equation of our normal, and we have to exploit the other point that we're given, right? We were told that our y-intercept, our y-intercept, now that you can see it, is c squared plus 1. So this is my y value. And then, of course, my x value for any y-intercept is always 0. So now I can plug this in for my x and y value, and then I can solve. So, what do I have here? Oh my goodness. C squared plus 1 minus the ln of c is equal to minus c times my x of 0 minus c. And now I have one equation with one unknown, so we're in the home stretch. Now I just need to simplify this side, so negative c times negative c is just going to give me positive c squared. This, for the time being, I'm going to leave b. C squared plus 1 minus ln of c is equal to this. Move it over to the other side. So I'm moving the c squared over here. C squared minus c squared plus 1. And then just because I know where I'm going with this, I'm going to move the ln of c over. If you don't, right after you cross out the c squared, it's going to become apparent. This and this cancel. So the ln of c is equal to 1. That means c is just equal to e. Whew, that was quite the adventure. Okay, so hopefully that question made sense. Again, I'm sorry if I rushed through it, but it's getting pretty late and I'm not feeling 100%, so I'm just trying to get through the last two solutions before I head off to bed. Okay, again, if you have any questions, ask me in class Thursday, because Thursday is just going to be a work period where we're giving you a practice quiz. So you have plenty of time to ask me questions, or if you don't, you have plenty of time to complete that practice quiz. So one more IB question, and then and then you can work on the rest of the handout. Sorry, there's more work to do.